Okay, welcome back students. This is the last session for today's class. I am going to solve the third problem of drawing number 9. The problem number is 2.3.12. This is a problem on circular lamina. I am going to demonstrate it here. You can watch carefully. This is your XY line. We are solving the problem in first angle projection. Now it's a circular lamina. Its diameter is not given, but what is given is in the front view it appears like an ellipse of major axis 30 mm and minor axis 15 mm. So the major axis is 30, that's the maximum dimension. So you should understand that the circle should be of the same diameter. Whatever is the major axis of the ellipse in the front view should have been the diameter of the circle. This is what you should understand. So we are going to start with a circle of 30 mm diameter in the front view and convert it into an ellipse in the second step. An ellipse of 30 mm major dia and 20 mm, 15 mm minor axis. 30 mm major axis and 15 mm minor axis. That's what I am going to do. So let us start with a circle of 30 mm dia in the front view. This is the circle, and I have to divide the circle into 8 equal parts because it doesn't have any corners. 8 equal parts means each division is of 45 degrees. Now I am going to start naming these points from here: A dash, B dash, C dash, D dash, E dash, F dash, G dash, H dash. So let us mark the dimension for the circle. The diameter is 30. So I will mark it as 530. Now the top view will appear as a line, and the line appears to be on XY line. So I projected all the points and I am drawing the top view here. Now this is the position of the observer. So E, D invisible, F visible, C invisible, G visible, B invisible, H visible, and A. Now this is the lamina in the top view. Now this lamina has to be made inclined to VP by rotating like this, such that the front view appears as an ellipse of major axis 30 mm and minor axis 15 mm. So it is this dimension, 30 mm dimension, which is common between the circle and the ellipse. That's why I have taken it here, 30 mm. That will remain the same even in the second step, which will remain as major axis. Okay. So I am drawing the major axis first here. So I can call this point as G dash, C dash. So I want the major axis to be 30, that is satisfied. And now I am marking for the minor axis. The minor axis has to be 15 mm. So from the center I will mark 7.5 mm this side and 7.5 mm this side. So this point has to be marked as A dash and this is E dash. So I am able to show only 4 points, whereas there are 8 points here. Now please follow how I am going to do it. With the help of these 4 points, I am going to get the inclination of the surface with VP in the top view. So before I complete the remaining points in the front view, I am coming to the top view. So this is A. This point I will project down. Yes. Now I am going to take A to E as radius. A to E, the dimension is 30 mm. So take A as center, 30 mm radius, you are going to cut this projector. This point will be E. And then you find the inclination of the surface with VP. This is the inclination, phi. And that phi should come to 60 degrees. So I am writing it down here. Now after marking A and E, you can mark the remaining points as well on this line by taking the distances. This is BH. The midpoint of this line will be CG. and you can also mark DF. So all the points are marked now on this line. Now you can project these points up. This line will coincide with, this point will coincide with that line, and this also you are going to project it up. Now draw the locus of all the points. Mark the points. Not only marking, you have to name them. B dash, C dash, then this is D dash, E dash, F dash, G dash, H dash. Now passing through these points, you are going to draw an ellipse which has to be drawn freehand. Freehand, you should make it appear like a single curve without any breaks in between. So this is the ellipse. This has the major axis 30 mm and the minor axis 15 mm. So this is your second step. This is SP4, this is VPC. You have satisfied the vertical plane condition. Now what is the HPC? What is the horizontal plane condition? It is given that the major axis should be parallel to both HP and VP. G dash, C dash, that is the major axis. Now right now it is perpendicular to HP. To make it parallel to HP, I must rotate it by 90 degrees. That is one condition. The second condition is one end of the minor axis is on both HP and VP. So A is already there on VP, so I also want A on HP. That's the condition to be satisfied. Okay, I repeat once again, there are two conditions to be satisfied in the third step. One is the major axis should be made parallel to HP. In other words, G dash C dash should be made parallel to XY. The second condition is this A dash should be taken on XY. So what you have to do? Rotation is by 90 degrees here. So first you should start by taking A dash on XY. Okay, and then you can draw the line A dash E dash perpendicular to XY. Okay, and then mark the midpoint of A dash E dash, draw a perpendicular to that, which is the major axis of the ellipse, and then you can mark G dash and C dash on that line. This dimension is going to be 15 mm. This is also 15 mm because the major axis is 30. So you have G dash here and then C dash here. Now once you have these 4 points with you, it's not difficult to get the remaining points. Okay, so if you want to get F dash and H dash, so I'll take this dimension. These points you can get by drawing arcs. This is your F dash, H dash, B dash, D dash. So you will get the ellipse like this. So you can see the major axis is now parallel to HP. Not only that, the point A is on HP. A is already there on VP. The condition says A should also be on HP. Once this is done, I am drawing locus for all the points. Project the points down. So A is also on VP. This is B. C, D, E, F, G and H. This will also be drawn freehand and this will also be an ellipse. So you will see that point A is touching XY line both in the top and front views. In other words, point A is in HP and also it is in VP. One more observation is that here, since we have rotated this by 90 degrees while going to third step, theta should be 90 minus 60. That is 30 degrees. In other words, the inclination of the surface with HP is 30, inclination of the surface with VP is 60. This has already been told to you in the class. So that's it. I have completed all the three problems of drawing number 9. In other words, we have completed projection of planes with this problem. So I just want to revise once again all the 4 simple positions with reference to projection of planes. If you remember, simple position 1 and simple position 2, you are starting by drawing the top view first. Once you start by drawing the top view first, what you should understand is, you will satisfy the HP condition first and then go to VP condition. Whereas, in simple position 3 and simple position 4, you are starting the problem by drawing the front view first. When that is the case, you will satisfy VPC first and then go to HPC. This is one important observation which you should have made. Okay? So when you adopt simple position 1 or simple position 2, you will satisfy HPC first. But when it is simple position 3 or simple position 4, you will satisfy VPC first. This you should understand. What is more important than anything else is identifying which simple position you have to adopt. This is very, very important. Okay? So once you go wrong in identifying the simple position, the entire problem is gone. This problem is for 30 marks in V2 exam. So instead of starting by drawing the top view first, if you start by drawing the front view first, then the entire problem is gone. Okay? So the first simple position is very, very important. If you go wrong in the first step, there is no weightage for the subsequent steps. Second step and third step, you will not get any marks. So first step is very, very important. In other words, identifying the simple position is very, very important. We have clearly, made the bifurcation between SP1, SP2, SP3, SP4. 4 different drawings we have given. I think 6, 7, 8, 9. Drawing number 6, drawing number 7, drawing number 8, drawing number 9. We have divided them based on the simple positions. And one more thing which I want to tell you, I think the previous problem, there is some correction in the problem. I'll just read out the problem. This is problem number 2.3.11. Whatever you have in the question bank, there is some correction to be made. Maybe you can make the correction once I read out the problem. This is how the problem should be. A hexagonal lamina of sides 25 mm rests with one of its corners on VP. It's not HP. It is resting with one of its corners on VP. Full stop. The lamina makes 45 degrees to VP and the diagonal passing through the corner on which it rests appears to be inclined at 30 degrees to HP. Draw its projections. That's the problem. So wherever you had HP, you should replace it by VP, and wherever you had VP, you should replace it with HP. So please make that correction in the problem. In the question bank, I think it was given wrong. So please make that correction. Okay. So students, with that we finish projection of planes. I hope this session through the video is useful to you. If you have any suggestions, if something is missing, you can give your comments online through the Google Classroom. And 31st is the last date. I'll wait till then. After your submission, I'll start with the projection of solids in my next class. See you then. Stay safe at home.